Hi everyone, this is a math guru. In this video, I'm going to show you how to solve the following optimization question. We have a satellite is to be constructed in the shape of a cylinder with a hemisphere at each end. The radius of the cylinder is r meters and its height is h meters. See the diagram below. The outer surface area of the satellite is to be coated with heat-resistant material, which is very expensive. The volume of the satellite has to be pi over 6 cubic meters. We have to show that 1h equals 1 over 6r squared minus 4r over 3b, and show that the outer surface area of the satellite can be given as s equals 4 pi r squared over 3 plus pi over 3r. And the last part of the question says calculate the minimum outer surface area of the satellite. We're going to start with the first part of the question that says that show that the height h equals 1 over 6r squared minus 4r over 3. From the question, we've been given the value of the volume of the satellite, that's pi over 6 cubic meters, and we know that the volume V of the satellite equals, we have the volume of the sphere plus the volume of the cylinder. Note that the two hemispheres, the one at the top, at the bottom, will form a complete sphere. So therefore, using the formulas given, I have that as pi over 6, as given in the question, equals volume of the sphere. From the formulas given, I have that as 4 over 3 pi radius cube plus the volume of the cylinder, pi r squared, times the perpendicular height. I'm going to simplify and make h the subject of formula. So starting with moving my 4 over 3 pi r cube, I have pi r squared h equals pi over 6 minus 4 over 3 pi r cube. Then I'm going to divide both sides by pi r squared. So therefore, my h will be 1 over pi r squared multiplying pi over 6 minus 4 over 3 pi r cube. If you simplify, I'm going to have the perpendicular height h of the cylinder equals 1 over 6 r squared minus 4r over 3. What I did was the 1 over pi r squared multiplies all the terms in the bracket as shown. And if you can see, we've been able to show that that is the value of h. Let's look at the second part of the question, which says, hence, show that the outer surface area of the satellite can be given as s equals 4 pi r squared over 3 plus pi over 3r. Note that from the first part of the question, we've been able to find the value of h to be 1 over 6r squared minus 4r over 3. So going to the question, to calculate the surface area of the satellite, we have surface area, I'll call that SA, equals the surface area of the sphere. I'm going to move that down here, plus the surface area of the curved side of the cylinder. So therefore, that is going to be 4 pi r squared plus surface area of the curved part of the cylinder, that's 2 pi r times your height. Note that we've been able to get the value of h to be 1 over 6r squared minus 4r over 3. So I'm going to replace that That's 4 pi r squared plus 2 pi r in bracket 1 over 6r squared minus 4r over 3. So therefore, if I expand by simplifying, I have the term outside multiplying all the terms within the bracket. I have that as 4 pi r squared plus pi r, or I have that as pi over 3r. Then I have minus 8 pi r squared divided by 3. And if I have the same terms, I have 4 pi r squared and 8 pi r squared over 3. If I group that together, I'm going to have, therefore, my surface area will be equal to 4 pi r squared over 3 plus pi over 3r. So therefore, we've been able to show that the surface area of the satellite, as shown in the question, is the same as our answer. Let's go to the last part of the question. It says, calculate the minimum outer surface area of the satellite. To solve that, I'm going to use the surface area. That is my SA equals 4 pi r squared over 3 plus my pi over 3r. If I rewrite that, I want to make my r, put them at the top. I have 4 pi r squared over 3 plus pi over 3 r to the power of -1 using my negative exponent. That's my SA. Therefore, I'm going to find the derivative of my surface area. So I have d of surface area dr equals, if I differentiate, I have 8 over 3 pi r minus pi r minus 2 over 3 equals 0. So therefore, solving for r, I have 8 over 3 pi r equals, I have my pi over 3r. I'm taking the negative exponent to the bottom. That becomes +2. Therefore, 8r equals, dividing both sides by pi over 3. So I have 8r equals 1 over r squared, cross multiply. I have 8r cubed equals to 1. Therefore, r cubed is 1 over 8. And if we find the cube root of both sides, I have my r equals 1 over 2, which is the radius. So the next step is to substitute the value of r into my original equation for the surface area. So I have then my S, or my surface area, will be equal to 4 over 3 pi of radius squared. Radius is now 1 over 2 all squared in order to get the minimum outer surface area. So I have plus pi over 3 times 2. 2, because I've been able to change. If I have 1 over r, this is equal to 1 divided by a half, which is the value of r, which is equal to 1 times 2 over 1, and that makes that 2. So therefore, my surface area will be equal to pi over 3, I'm simplifying, plus 2 pi over 3. Therefore, my surface area equals pi square meters, or 3.142 square meters. Thanks for watching. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. Bye.